Okay, so we talked about 0. So what is right? Let's go blue and okay. Why is this difficult? Why is the things not correct? It's like well, that's recording. So.
Okay. Oh, I see. You don't have like a little page thing up that everybody else generally does when they write.
Oh, right, I need a new page. So plus new page, right?
Good job, Richard.
Where is the plus page?
Bio, edit. Let's use it.
It should just be a click. Just the
Maybe
one
you
click.
click
Is
it.
it click? Nope, that's not it. It's like that.
There we go. There. That looks right.
That worked, right?
You can write.
All right, now I can write. Beautiful. We'll get there someday. So.
Yes, technology.
0. Some other things. So here we're going to discuss some other things about 0. So 0. What is 0 divided by, say, a number like pi?
Zero.
What's that?
Notes.
0 is the topic.
Okay.
We'll call it that the topic. So 0 divided by pi is independently 0. Okay. Okay. What about 0 divided by, say, some complex number of 1 plus I? What do you think that is?
0.
Okay. Also 0. Correct. What about if we have, say, some constant, say like 3 divided by 0? What is that?
Undefined.
It is unreal. No, it's undefined, right? Okay, so why is it undefined? Well, you could argue that division is the reverse of multiplication, yes? You could say 0 times 1 plus I, right? We could say that that is definitely 0. The 0 times pi is definitely 0. And what times 0 gives you 3?
Nothing.
Right. There's no real number or even a complex number that we know of could give you 3, right? So what is 0 divided by 0?
0. Nothing. But yes,
everything. Because you can multiply anything by 0 to get 0.
Okay, so we have once again saying that everything.
Whoa,
So
oh my God.
all solutions,
So all
0.
Yeah,
all
it's everything and nothing. That's the universe right there. That's the answer to life, the universe, and everything. It's not 42. It's 0 divided.
What? This is so. This reference. It's basically our own.
Okay. So why can't it be a complex number?
I don't know. We have special rules. Because they're not real numbers. See, but if we put that into a calculator, you get a 0.
So
I mean, it's
0 divided by 0 is undefined.
Oh, hey.
Because technically, if you divide anything by itself, it should be 1, but it's not really in this case.
No, now everything has changed again.
So, okay, so the argument, okay, so why is it not any number? Why is it not, why is it not all solutions? Right? Is because it's just an expression here. It's just an expression, so shouldn't it just simplify to either some sort of single value or not be defined? I mean, it's not really an equation, right? It's just simplifying here.
Yeah, it's like a fraction.
Okay, so long story short, it probably fits the same answer as to why, mathematicians probably just said it's easier to do it this way. It's probably easier to find this way. So let's talk about some other things. So we have, what is 0? 0 squared is what? 0 squared is 0, okay. What is 0 to the first power?
No.
I like how we have different things going on here about these things.
Everything's no. Anything to the 0 power is 1. Yeah. Oh, that's it. That's what being 0. So it's still 0. So it's 0.
Okay. And what is 0 to the 0 power?
1.
It is 1. Very good. So it's a good review on some fundamentals of 0. Okay, so let's talk about some limits. You guys should know, have some ideas. So say the limit as, say, some independent variable approaches some constant of, say, f of x over g of x. And let's say this limit gives you something like 0 over 0. So what was, by itself, what was 0 over 0? 0 over 0 is undefined. But if we have a limit, the value of a limit is 0 over 0, is that still undefined?
Sorry, what do you mean by the term limit?
Yeah, we actually never.
Really? Okay, so in pre-calculus, you should have absolutely discussed limits.
We really deep briefly. We wrote out limb.
Okay, so the fact that I have some of you, even just a few of you, if there's a few guys, I'm going to go into it anyway. So what a limit is, so a limit, this is important, so a limit is the value a limit is the value, say, a dependent variable. No, let's not even say that because we have two functions here. Let's make it crystal clear. I like to be very crystal clear because I'm a math guy. So limit is the value. I'll say the value we are approaching as, say, an independent variable approaches some value. So what is key here is this right here. Why is that key? Because sometimes you may never actually get to where you were going. Ignore that bell too. We got a lot more to go through. What's that? So we have an issue here where, let's understand this first. So what we are approaching, we may never actually get there, but it could be what you are approaching. Even though a value does not exist at that point in time, a limit could exist. Okay? So the limit is the value we are approaching, and this is very important in the study of calculus because we deal with values that we are approaching, even if we never absolutely get there, and we can never actually pause reality at an exact point in time. Okay, so what we are approaching as an independent variable approaches some value. Okay, so new slide.
So is it similar to an asymptote, or?
Is what similar to
A limit.
A limit is just the value that we are approaching.
The limit?
Asymptotes may be involved in certain functions, and then you go, okay, let's find the limit as x approaches 3.
I think are you asking
So
is the limit only like a possibility in an asymptote?
The limit would be like the line that the asymptote is going.
Yeah, okay.
So
Like that value that it never.
let's review what an asymptote. Let's review what an asymptote is. Let's say a vertical asymptote. A vertical asymptote is just says there is no value for this. We're talking about one specific function. There's no value for this function, say at this point. Say for this example, we'll say 3. Okay. There is no value. So if we graph it, let's go with green. So let's say we have some function that looks like this. Now the green is the actual graph of the function.
The limit is
Okay, so let's say this is the function f. Okay, you sometimes see it. So we're all clear on the notation. Sometimes you see just f written, or you'll see f of x is very common, specifying what the independent variable is. We say we let this axis be the x-axis and let this be the y-axis, right? What's that?
The difference between, like, there's a lot of different notations and everything that mean the same thing as over here, and, sorry, go ahead.
So again, we can just say this function is f. We can say it's f of x because obviously we're showing a relationship between, let's say, y, the dependent variable, and x. And in this sense, we could say, okay, let f of x be y. You see that a lot in textbooks as well. Okay. So let's say we want to know what the value of the limit of this function. So what is the limit of f of x as x approaches 3? Okay, now this is actually very convenient because we have a graph. And this is an instance where graphs are so nice because you can quickly see it. Yes? Okay, so let's go into this. So the limit of f of x as x approaches 3. Okay, am I specifying which side I'm approaching 3? Or is it not specified?
Either side. Going to-
It is either side because I did not put a little plus sign or a little minus sign in the upper right here.
Yeah.
It would say,
Okay, so-
X arrow
All right.
3 minus.
So let's say
Or X arrow 3 plus.
we had a plus here. What this would mean, and this recorded video I eventually will upload as soon as I set up an account and you guys will have access to this. So what this means is, what is the value, what is this as x approaches 3 from the right-hand side of this function f of x? So what we can do is we could start from anywhere to the right of 3. I don't have to start way over here. I can start really close. It doesn't matter. Just start somewhere to the right of 3 and trace it along and see what value f of x is approaching. Is it approaching some value?
It just keeps going, so it means infinity.
So with this vertical asymptote written with a dashed line, it is implied that this function is approaching, is going to negative infinity. Now, is negative infinity, is that a limit, or is that an oxymoron? To say a limit is negative infinity or a limit is infinity, because the limit infinity, does that make sense?
Yeah, I get what you're saying, you know.
Right? So here's the problem with some textbooks. They'll say this, and they'll walk away, and that'll be the answer in the back of the book, and that's absolutely incorrect, because negative infinity and the limit, that's an oxymoron. So, there is no limit for this.
Oh.
For what
We're
would
getting
the
there.
test say?
We're getting there. The test will say this, because I will write the test.
So limit is gonna be normally, like, if it would be negative infinity, we just put no
Yeah, you don't even have to write this part, but this is absolutely important. I do not want you to leave it like this, because what that tells me is that maybe the student thinks that negative infinity is a limit, and that's not true. It's an oxymoron. The limit is to be negative infinity, yes.
Now, you couldn't have x to like the 3 negative, right? Because it's only on the right side of the asymptote.
So 3 negative would be negative.
Are you asking if could we find the limit as x approaches 3 from the left hand side?
When you got the function, it makes
It goes.
Yes, let's be clear. Everything that's green on here is f of x.
Okay.
So this, good question. This and this is f of x.
Okay.
So that's 3 minus 3 is the other one.
It would be positive infinity
Or, no,
It's still no limit though.
Yeah, so there'd be no limit even if we were correct. If we approach 3 from the left hand side, you're right. There would also be no limit because it's going to infinity. Infinity is not a number. Okay? It's just an idea of forever in some direction. Okay? So the limit as x approaches 3 from the right hand side, no limit. The limit as x approaches 3 from the left hand side is also no limit. Oh. Coincidentally, that'll work. I guess.
So if you had a horizontal asymptote, you'd have an actual number.
Okay, good. So we can get into that as well. So let's. Is there? Okay, let's say this. Is there a horizontal asymptote? Since it's been mentioned. Yes.
Yeah,
Does
yeah.
it appear there's a horizontal asymptote?
Yes.
Yeah, it's right on the axis, it's right on the axis.
It lies on the x-axis. And what would the equation be for that horizontal asymptote?
Y equals
Yeah,
I
like,
don't know, you guys want to approach 0 x equals that, so instead of looking at the function, we're looking at x.
Okay, so he's saying if we let y be the independent variable, which is untypical, but let's say we do that. If we let y be the independent variable, what is the limit as y approaches 0? So now you get to see the way he's saying it, which we will not do this, but it is fine because I appreciate the mathematical thinking. If we approach as y approaches some value, say y approaches what, 0? Then what is the limit? So now you have to read the book like this. If you were to do that, we're not going to do that, but we'll do it for this particular example. If your head hurts, maybe that's a good thing, I don't know. So as y approaches 0, what is x approaching?
It's approaching 0. No, it's not approaching 0. It's approaching 3.
It's approaching sort of, right? If it's going towards
Does
that
it matter?
line-
So if we approach 0 from the bottom, we have this going on. If we approach 0 from the top, we have this going on.
Oh, so it would be no limit.
So it would also be no limit.
Oh, okay.
What's the scenario where you look
Yeah, that's my
at?
question.
It stops on acid, right?
What's that?
So it would be
Is it
like,
like even a thing? Asymptosis is where you can never touch.
Or what do you mean unlimited
it's
thing?
always no limit, just don't do that.
Wait, what do you mean limits? Are they a thing? What do you mean by that?
Because like, every time we learn that these are things, and this like actually works. I know you're saying
Yeah, that's what I'm asking, you. What is the scenario where there would be limit?
We have different
Okay, when studying mathematics, I don't want to say don't focus on whether it works or not, because it may not be exactly what I want to say, but math doesn't care if things work out or not. That makes sense. It's kind of like if you study any sort of science and you do some sort of testing, right? The testing doesn't care what you think or feel or think it should be. But you ask if limits do exist. And I'm going to give you an example of a limit that does exist. In fact, I'll use this very same exact function. So let's go make up a point here. Let's say at this point here, let's define this point as, it looks like it's 1.5, 1.5.
Bringing up the decimals.
Bringing up the decimals.
I think it
Come
looks
decimal.
more like
Yeah.
And
It was more like
1.
2-1.
I'm a teacher, so it's 1.51. Let's go with that. All right, so that point is 1.51. What is the limit of f of x as x approaches 1.5?
Wait, can you say that one more time?
So what is the limit of f of x as x approaches 1.5? What is that?
in which direction?
Doesn't matter because I'm not specifying. So therefore, it would need to match whether you approaching 1.5 from the right-hand side or approaching 1.5 from the left-hand side. They better match. In order for this limit to exist, they better match.
It will always be one.
Remember that.
Yeah, it can't be higher than 1.
Can't be higher, can't be lower.
Okay, so let's trace it. This is how you would do this. This is very nice because it's a graph. It's already given to you. You can just trace it. So let's approach 1.5 from the right-hand side. Okay. As I get infinitely closer to 1.5, what value am I approaching?
1.
Correct. Let's approach 1.5 from the left-hand side. As I approach 1.5 from the left-hand side, what value am I getting infinitely closer to? 1. So it is absolutely 1. And this may maybe go along with what you were discussing, like are these real or do they exist? Here's an example of a limit that does exist. Yes?
Does the limit still exist if it's not the things off the list?
Good question. So we can do, I'm going to do more and more examples. I like the questions because it's going to lead me to other things. So now let's go back to, and another thing too. So you asked if limits are important. Is that kind of your thinking? Are they important?
We were taught like negative and positive infinity, but now we're new limits.
And that's why I make this distinction because there are a lot of misunderstandings in the world of mathematics. And they leave it like this. The back of the textbook will leave it like this as an answer, but it's negative infinity limit. That should be an oxymoron in your mind. Like I have infinite money. How much money do I have? Is there a limit on the amount of money I have? I have infinite money. No.
See, we use the different concept that infinity actually had numerical value. So
That's the thing about math. Infinity is not a number. Let's be crystal clear about this.
Negative infinity and positive infinity are different, so shouldn't it be like negative no limit or something?
Okay, so let's make a whole slide here. This is good. So
Large amount of numbers.
infinity
How is that negative?
is an idea.
So infinity could be infinity, it's just no limit.
Infinity is not a number. Now, I'm not going to be a Nazi and give you 0 points if you leave the limit, evaluate it as negative or positive infinity, okay? But I do want you to be clear, absolutely clear for your knowledge, that infinity is an idea and infinity is not a number. Okay, it should make no sense to say the limit of something is infinity and leave it at that.
But doesn't it represent?
That means it's an
numbers?
oxymoron. Okay.
But doesn't it represent numbers?
No, infinity does not represent numbers. Infinity is like a direction. It is to go on forever,
In a certain direction.
but it's not a defined number. I'll give you something that might, okay, to give you an idea as to how badly people do not understand infinity. It's this, and this still is mind-blowing to me. If you believe in the theory of parallel universes, and that there are infinite parallel universes, and this is stuff you can see with the guys that are PhDs that are way above my thinking, so I'm standing on the shoulders of them for right now. There are an infinite number of you doing an infinite number of different things right now, if you believe in that theory. So there is another one of you sitting in a math classroom in another universe with a red folder. Everything is the exact same. But there's also another one of you that has maybe the red folder is tilted slightly off. And there's another one of you, so infinity is a concept that is truly mind-blowing, but we're not going to get to. That's very philosophical and physics, and we should understand that infinity is not a number. It's just to go on forever. Anyone not understand? Or yes?
I do understand that there are actually different theorems and different ways of presenting infinity as either a numerical value or a concept. So I think either way is really right. The book is not entirely wrong, but it's not entirely right either.
There are different types of infinity,
Right.
but infinity is not a number.
But they use infinity to represent all negative numbers. So if you have negative infinity, that means that all positive numbers are excluded.
Yes, that's what I meant. So isn't that keeping out some of them in a way?
No.
Like if you go on forever in this direction, you're excluding everything in that direction.
Not especially specifically when we're discussing limits, it's not like there is some value that it is.
So in some cases, like what they were saying, if it's like a group, you talk about a group of numbers, negative infinity, or it's all negative numbers, but in this case, when infinity applies to limits, it does not represent a number, it's the concept of forever. Is that what?
Yes, it's the concept of
Okay.
forever. It's a direction
But
thing.
in other scenarios, it might represent a group of numbers,
No.
or no, in other,
Absolutely not.
in like a group, like what's the thing in like geometry where you have like groups and stuff?
Here's an easy way to represent. Here's an easy way to represent all negative numbers.
Yeah.
I was always told that was negative.
Or less.
I'm sorry you were told that infinity or infinity is a number. It's not a number.
Write it down.
Guys, let's stick together as a group. When someone speaks, listen to them, and we'll go back and forth. Yes?
So does it, you don't have to specify whether it's going like up or down?
No, I don't care. I'm more interested in this being your answer than leaving it like this. Because this implies to me as your teacher that you say negative infinity or positive infinity is a limit.
That's
of
you.
Yes.
Okay, yeah, I have a question then.
Yes.
So say that the limit of x as x approaches the negative infinity, would you be able to use an infinity as the answer?
No. The limit as x approaches negative infinity of f of x is 0.
Wait, say that one more
So
time.
those boxes stay so long. Because, again, let's go back to the definition of what a limit is.
So if you go to the positive infinity, you would be 3 in that graph.
This is why this is in a red box. This is something you guys need to understand to get the fundamentals behind calculus, is that the limit is the value we are approaching. So if we go back to here, if x approaches negative infinity, and there is a horizontal asymptote at y equals 0, we agreed on that. Does a limit exist as x approaches negative infinity?
Because it'll eventually.
Right, because so therefore there is a limit, because the limit is the value that we are approaching.
Okay, but if it's an asymptote, would it just be a negative infinity?
No,
No,
because
the
look,
asymptote is approaching 0.
I want you to imagine that I'm going to keep walking. Am I ever going to get to y equals 0? Am I ever going to intercept y equals 0? No.
No.
No, but will I get infinitely close to it?
Yes.
So it's approaching 0. Let's say that the asymptote wasn't there. Say the only asymptote and a half is
So
3.
in this case,
Mm-hmm.
Would it be negative 50?
3. But in this case,
Therefore,
x approaches
no limit.
infinity that way, it's negative and negative.
Get it, I get it.
We can pick back up with this.
It's not a number, how can you approach it on a number?